Good morning, everyone. This is Mohammed, and it's Sunday morning, 7:30 UK time. And in this video, I'm gonna take on the first task of week 76. Okay, I'm not sure if you noticed this weekly challenge page has changed slightly. It's because someone just reached out to me a couple of days ago suggesting that I should have a link at the top of the page to the task. Because normally, if you notice, if I go back to the past challenge, for example, if I go to challenge number 75, so if you see, there is no link to the task. So if you want to go to the task, you have to scroll down all the way here to get to the task. So what the suggestion was to have something at the top so we can jump to the task straight away rather than me scrolling down slowly. And I like the idea, so that's why I thought, okay, why not change it? It looks nice and clean. So yeah, thanks for the suggestion. And however, it's slightly annoying issue. So if you notice, if I click here, it doesn't go straight to the title. It goes a couple of lines down. So it was here instead of going there. I have no idea why it is happening. It could be the Go library that I'm using to generate this static page from the markdown, because I follow the suggestion which I found online how to create a link in markdown. That works. If it is just a plain markdown, it works fine, no problem at all. However, it doesn't work when Hugo comes into the picture and try to generate the static page. There's something which I am unable to decode it. If you know, please let me know. Otherwise, it's not bad. It's acceptable. So let's start with the task, which is prime sum. So what is this? So this task is you are given a number $n. Write a script to find the minimum number of prime numbers required, whose summation gives you $n. Minimum is the keyword. So, and also it's made an assumption in the task saying please assume 1 is not a prime number. So let's not discuss that. Let's not go there. So if the input number is 9, output should be number 2, not the individual prime number, is what I expect. If you give this fine, if you give 2 and also give what are the two numbers, then even better. Because if you sum 2 prime number, 2 plus 7 gives you 9, so that you need minimum 2 prime numbers needed, i.e. 2 and 7, to get the sum 9. Okay, so for this task, the prime numbers, I'm sure every one of us have come across this number, and there are many ways you can figure out you can do this task. And my math background wanted me to do something different. So the first thing that comes to my mind was I am going to follow a certain path. For example, my first thought was, okay, what I want to do, I want to create all prime numbers up to the given number. So if the given number is 9, I'll create every prime numbers that's up to 9 or less. And then once I have the list of all the prime numbers, I'm going to use one of the good old CPAN modules, algorithm combinatorics, to give me the different possible combination using the list of prime numbers. Once I have the list of combinations, it's just a matter of checking which list, which combination gives me the sum, and that's my answer. So that's the plan. Okay, but the next thing comes, the next step is how I'm going to find out the list of prime numbers up to the given number. So far, I've done, here's a number, tell me whether it's a prime number or not, kind of thing. Never done, okay, give me all prime numbers up to this number. So I thought, okay, let's Google it, see if we can find anything easy and elegant way. And during my investigation, I found out this wiki page. It's called Sieve of Eratosthenes. Never heard of it before, but seems to be very common in mathematics field. And I feel ashamed not knowing this, having the maths background. Okay, let's put that aside. So what does this say? Because it says in mathematics, the sieve of Eratosthenes is an ancient algorithm for finding all prime numbers up to a given number. Exactly what I was looking for. See, I'm so lucky. I found this page. So this is exactly what I was looking for. An algorithm to find the prime numbers up to a given number. Exactly. And how you do it? So if I go to the example straight away and directly. So here's an example. So to find all the prime numbers less than or equal to 30, proceed as follows. Okay, what do you do first? First generate a list of numbers from 2 to 30. No big deal. Then the first number in the list is 2. Pick that number. That's your prime number. And then cross out every second number in the list counting up by 2, i.e. multiple of 2. So you cross out 2, 6, 8, 10, blah, blah, blah. And then you have a shrink list now. Now pick the next number in the list. So after 2, the next number is 3. You go do the same thing. You cross out the multiple of 6, leaving 3. And then you shrink the list. And then you find the next number after 3 is 5. Again, 5 is your next prime number. And then you cross out all the multiples of 5 after that. And then once you have done, you keep on going unless you reach to the end. Once you reach the end, this is what you get. And that's your list of prime numbers up to 30. Which is simple and very straightforward. I didn't bother looking through this pseudocode. It requires a lot of patience to understand. It was easy to understand this example. So I thought, okay, I'm going to use this example and I'll code it and create my own function to get the primes up to the given number. Okay, let's start. Usual ch1 pl user bin use strict use warnings. So first thing first, I'm gonna not bother this bit. only parameter I'm needing is $n gv0. Should I give a default? Let's give the default 9 as an example. I'm going to create my methods. Okay. The first method I want to do is find prime up to the given number. So here is my num. Just do basic parameter checking. Basic number. Invalid number. The number should be positive, so I can do something like this. Okay, that's done. So first I need to create a range starting from 2 to the given number. So let's call it, my range is going to be mapping this, creating a reference to a hash, reference to a list of key values. So it's going to be 2 to excuse me, so 2 to given number. So that gives me the range to the given number. So I have to just play with this range. Let's create a placeholder to hold my prime reference to a list. Let's start with excuse me, 2. So we want to do, unless anything left in the range, first push that I to my prime. That's my prime number. So prime $I, and then I need to find out my next prime in the list, which is gonna be, I need to create a method which do sieve of Eratosthenes. So find next prime. So let's create a method which will use sieve of Eratosthenes. first thing I need to do is sort the range numerically, because we have to pick the first available number. Okay, so and I'm going to delete all the multiples of this given I. So for each small $j sort $a $b keys $range. And what I'm doing is I'm deleting range $j unless there is a remainder. So it's a multiple of I. So if it is not a multiple I, if it is a multiple of I, I'm going to delete it. And then once you have removed the multiples of given number, find out the first available number in the list, in the sorted. So you're gonna be, so my next I is gonna be sorted list of $A, $B, keys, $H, first element in the list. And in case there is nothing formed, because this gives me, for some reason, giving me this string form of a string representation of the number. So to get rid on, what I'm going to do, I'm going to just add 0 if you do find $i. Because what if there's nothing left in the list? I don't want to do plus 0 to under. So if it is defined, you add 0, so make it a number, and then give me the, return me the list. My next number to play with, and the updated range for my next round. So this will become the $i $range is going to be C of teens class. Okay, and if you can't find any more number to do the cleaning, come out of this lost unless you find this while loop, and then return the prime. That's my list of prime number up to $num. Okay, so that's the base done. Now is the time to find the prime sum. Let's create a method. Find the prime sum. Prime sum. So it's gonna be you're gonna give me the list of primes all the numbers up, prime numbers up to the given number, and the sum that I'm after. let's create a placeholder to have prime sum. So prime sum, all the possible combinations are going to be there. So what are we going to do? So using, I remember I told you I'm going to use sieve model called algorithm combinatorics W combination. Okay, so what I'm going to do, so I'm going to start with for each my $I1 dot dot $sum. So why I'm doing this? If you know this combination method from this sieve model can give you combinations, all possible combinations of the given list. But what I wanted to do is I wanted to do combination in turn. For example, if I say give me a combination of one member each, then two member in each list, 3, 4, 5. The reason I wanted to do this because since the task says we are only interested in the minimum number of prime numbers. So if we create a combination of 2 in a list, and if I find my sum among those, no point going to create 3 member list. What's the point? Because we are only interested in the least number. Having said this, I saw other members finding all possible pairs, all possible combination that gives the result. So I said, okay, let's do it. Let's get all possible combination that gives the result, which give the same sum. So that's what I'm saying. So I'm going to do this. $I is going to give me the partition count, and once also this bit is during my testing of I found this. I have to put this test. So if $I goes beyond the list of primes you have in the list, don't do, just come out. Because say suppose you were trying to figure out a sum of say 50, just for sake of argument, and the total number of primes you have in $primes is say 20. So you don't want to go through 1 to 50. Since you already have 20, you only want to go up to 20. So you want to have a partition from 1 till 20, because there are no more than 20 elements in the list. So this is important. So I found it during my testing. So just catch here. Now let's go through the combination. So my $comb is going to be the combinations method calling passing the list, which is my primes, and the partition count, which is I for now. So starting with 1 member partition, then followed by 2 member partitions. Now just a matter of finding the sum of each partition. Starting 0, and then $sum plus equal $_ for $com. You sum each member of the partitions, and that gives me $_sum. Now you push prime sum this combination if and only if this sum is same as the given sum. Simple. once you're done gone through, just return the prime sum. Prime sum. And I'm going to create just a handy method to print this result. So I'm going to just create a method called print. You give me the prime sum and I print it for you. So it's going to be for each prime sum. No rocket science, just print the value. Printf. So now how I'm going to call this? So it's going to be something like so let's print some usage before we jump on. So let's print usage 0. Give me the positive number. And exit unless defined. Alright. Now call this method print which calls prime sum, and it's gonna get prime up to sum. Confusing? So first you're gonna get the list of prime up to this. That's the first method call, and then we're calling prime sum, passing the list of prime up to and telling me find me all the combination for this sum this, and then once you want the prime sum done, you say print. Hope this should just work. Very sum. Now it's n. Line number 48. And 7. So what if I say 20? Perfect. You see, these are the possible combination. 3 17s, 7 13 2, so nice and cool. So yeah, that's it. It's a nice learning for me as well about this beautiful algorithm called sieve of Eratosthenes. Didn't know about this, so thanks for this challenge, weekly challenge. I learned something new. Thanks for watching this video, and if you do like this video, please subscribe my channel, and so that I can continue doing this every week. So very soon I'm going to come back and do the second task of week 73.